All right, so 2.2, we are starting with the very basics of solving inequalities. The very basics. We're going one step, just addition and subtraction. That's it. Okay. So basically what we did in the warm-up, just with an inequality sign. That's what we're looking at. Okay, so let's look at one example to start here. Let's go -6 plus x is less than -10. I want you to go ahead and solve that, and I want you to graph your answer. We talked about this. I want you to solve that and graph your answer. Solving and graphing here. Okay, when I talk to somebody, see if they got the same thing, see if the graph looks the same here.
Oh. Yeah, that's the right answer. That little circle. So at first it was this, and then so I almost said because it didn't really yeah. We're playing in the half year, and then we put the foot underneath.
All right, here we go. So we add 6 both sides. We get our answer. We're going to solve it just like there was an equal sign. And guys, this right here, this is another reason why we need to show the work and do the work correctly. Because if you're just looking at this and saying, yeah, a -4 goes there, and you just put a -4 in for x, that doesn't tell us the solution, right, with the inequality sign. So like I was talking about in the warm-up, we have to do the work. We have to get it in the right spot here. So we end up with x is less than -4. Great. Before we graph, this sort of stuff right here, we can't be making mistakes on that kind of stuff anymore. -10 plus 6, we have to know that that's -4. If you don't know that that's -4, first of all, you should be practicing it. Okay? Go old school, get some flashcards, find something online that's going to help you. Do your rocket math from elementary school again, or whatever you got to do. But we got to be able to get this, no problem. Okay? I hate marking people down on quiz and tests because they do everything right, but here they did -10 plus 6 is -16. Or even worse, I see people do something like -10 plus 6 is -10.
What?
It's not, right? Like, so, but people make that mistake every single test, every single quiz. Somebody's making a mistake like that. Okay, I would love it if I got through one entire day of grading tests where I didn't have to do this and put that next to it and be like, what are you doing? Okay, so take the extra 3 seconds on the quiz on the test and double check it, or hey, you got a calculator, type it in just to double check. Okay, don't be afraid to do that, especially on a quiz test. All right, so we're here. We know we got 3 numbers that need to go on the bottom. Our answer is going to go in the middle. Okay, our answer is always that middle number. Raise your hand and tell me what numbers are going to go on either side here. Brent? -5 and -3. And they have to go in that order. Okay, it's got to be in that order. You cannot switch them around. Our number line has to be smaller numbers on the left, bigger numbers on the right. So we're getting closer to 0 when we're talking next. All right, is this going to be open circle or closed circle? Open. Open. Is our arrow going to go to the left or the right? Left. Okay, it's going to the left, not just because this is pointing to the left. It's going to the left because our sentence says that x is smaller than -4. And we know all the numbers that are smaller than -4 are the ones to the left of it. Okay, so we're always thinking about what is that variable in relation to that number. It is smaller than the number, so our arrow is smaller than the number. Okay. So that's just a reminder on how we graphed yesterday. Okay. as long as the variable's on the left. Yes. All right, let me give you a couple more here. Throw some fractions, some decimals at you, make it a little bit harder at least. We're gonna do both of them here. Solve and graph for both of these, please. Solve and graph for both. Of course, we need to use calculator, feel free to use calculator. If we don't, we don't. No. But you have to check somebody, make sure their numbers are the same as yours, or that their numbers work on their number line.
I got the answer. I got it.
That's also. I'm not even lying. I'm not in my number. I'm not even lying. I'm actually so smart.
X is what? Let's do 4.
I got 0.5 is greater than y, and I got
What? Oh. Oh, me too.
and then for the second one, so then I got open circle one is correct.
All right, here we go. Here we go. So we add 1/4 both sides, we get 2/4. However, something's not right about this. What do we have to do? Gotta simplify the fraction. Okay, gotta simplify the fraction if you can. So that's down to 1/2. So we've got it here. If you want to, you can flip that whole thing around and write your answer as y is less than 1/2. You just need to make sure that the y is smaller than the 1/2, whichever side, whichever way you write it. It does not matter. Okay, both of these are correct. Now, when we go to write our numbers down, we know we got 1/2 in the middle. Raise your hand and tell me, what did you put on either side here? Emma, what'd you put?
I put 1/4 on the left and I put 3/4 on the right.
Okay, anybody write anything different for that lesson?
I put 0 half on the left.
Okay. Okay, and 0/2 would be 0 and 2/2 would be 1, right? So we could do that same exact thing where we just have 0 and 1. As long as it's the same amount on either side, then we're okay. Because we're gonna evenly space those marks. We want it to be the same amount on either side, whether that's a fourth, whether that's a half, doesn't matter. Okay?
What if I put it as a decimal? Like what if I just-
Well, this is very specifically has fractions in it, even a fraction. Yeah. All right, open or close circle? Open, arrow to the left or the right?
Left.
Left. Y is smaller than 1/2, right? Y is smaller than 1/2. My arrow is smaller than 1/2. Okay. Over here, add the 4.05. We have 4.12. Raise your hand. And tell me what numbers did you put here, Chloe? 4.11 and what? 13. Thank you. I just said 15 for a second. 13. That works. I might put something different than that. Terrence?
I put 4 on the left and 5 on the right.
Yeah, so let's be careful with that. If we do 4 and 5, right? 4.12 is not halfway in between.
Oh, it's 4.24.
So you can do that, right? 4.24. You can do that where it's halfway in between. That would work, right? Yeah. Okay. Yeah, the other one that I've seen recently today would be like 10 and 14. That's fine. We can do that. Right. I would try to stay away from, I had one person earlier do 3.12 and 5.12, which yes, technically would work, and I probably wouldn't mark you down for it. It's just weird. We typically don't count by ones when it's not a whole number. I would rather get down to that decimal level on it and do like a 4.11, 4.13. Okay, we got closed circle, arrow to the left or the right?
Right.
To the right this time, because X is bigger. So X is bigger, arrow's bigger.
Would it be okay if we did a 3 and a 5?
They did a 3 and a 5, like 3, 5, and then 4.12 in the middle. I would not necessarily like that because this is not exactly halfway between these. I'd rather have two numbers that is exactly halfway between. Because 4, if it was the number was 4, then yes, right? But then our dot would be like here, 4.12. When we create our own number line, we want the numbers to be evenly spaced on our number line. Okay, just makes it a little bit cleaner for us. All right, any other questions so far about this? You'd be able to do this if we were subtracting from both sides, yes?
Yeah.
We don't have to practice that? Great. All right, so let's look at a word problem. Because we need to be able to create an inequality. And when we create the inequality, we've talked about this before with equation, we want it to be something that we can solve, right? We don't want to have to do math before we create the inequality. So here's our original problem. I covered up the second part of it, which we'll look at in a second. But it says a circuit overloads at 1800 watts. You plug an amp in that uses 900. The question is, we want to create an inequality to figure out how many more watts we can plug in. That's what we want. I don't need an answer, right? I want an inequality that I can solve to get that answer. So with person next to you, I want you to create an inequality for that problem to figure out how many more watts we can plug in. Okay, go ahead and talk to each other to figure it out.
Okay, so I was thinking that would it be 1 is greater than y? Would it be y is greater than you can't plug it 2 because then that's when it overloads. I was thinking that maybe it should be y plus x is greater than, less than or equal to 180. No, but it overloads at 8. Yeah, and it overloads at that, so we can't plug in anymore because then it'll overload. So less than equal. No, it can't be equal to, it's just less than. So it'll be y is less than 1000. Right?
Yeah.
Can it go up to the 180 mark?
It says it overloads at 1800.
See, I told you. Yeah, it'll be y.
You don't have to graph.
It's less than
Just the
1000.
inequality. No graph here, just the inequality.
Would it be 2 or 1000?
You can solve.
I think like if we're pushing an absolute value thing, it would be. We're not doing absolute value. I know, but if we were, because I'm bored and it's a sound test, if we were to be x minus 900, you can't do it. No, you could. No, you could. If x equals 2,700. Huh? Actually. Yeah, you good. Good. My jacket.
All right, here we go. Raise your hand. Tell me what inequality could we use to represent this? Sharon?
I had 1800 is greater than 900 plus W.
Anybody have anything different than this? Wes?
I have x plus 900 is less than or equal to 1,799.99 repeating.
Okay,
That makes 18.
Can you simplify that?
No, but that,
so,
If it's repeating, it doesn't.
so
has to like screw it up.
it's beyond what we're talking about today.
He's not
But
wrong.
1799.9 repeated is the same thing as 1800.
Yes.
It is. It is. Didn't we talk about this the other day?
No,
About how 0.9 repeated is equal to 1?
no.
Okay.
Really?
Let's real quick talk about this, right? Nice sidebar. Nice sidebar.
You should put 0.444.
What's the decimal equivalent for 1/3?
0.33.
0.3 repeated, right? Okay, if I add 0.3 repeated and 0.3 repeated and 0.3 repeated, what does that give me? 0.9 repeated. What's 1/3 plus 1/3 plus 1/3?
3/3.
3/3, which is,
1.
so 9.9 repeated is equal to 1.
Ah, I like that.
I had to prove that in college. All right, long time, so you don't have to worry about it. Okay, go ahead.
899 is more than or equal to x.
899 is more than or
I
equal.
don't think that's right.
We'll get there. We'll get there.
I think it is true.
We did a little bit of math first there. Okay, we're trying to make something with a variable where we need to actually solve it. Okay, Kayla?
800 plus x is less than 18.
Less than 1800. Right? Okay, which is the same thing as you, right? The same, just flip it around. Okay, that's right there. These right here, these are the ones that are going to work. Okay, first of all, well, we already said that this is equal to 1800, and it can't be or equal to, or else we're going to overload it, right? So that's why I'm going to take that one out. This one we could have 899.9, right? We could have 899.97. As weird as that sounds, right? The number of watts. So we can't have that greater than or equal to, or less than or equal to. Okay, it's got to be something like this. So when we solve it, we subtract the 900. We're going to end up here. Now, part of your homework is going to say to interpret what this means. Interpret the inequality. How would you say what this represents in terms of our problem here? Yeah?
The amount of more watts that you
Is,
can
there you go. So when it says interpret, we want to use the numbers. So we would say the amount of watts or the number of watts that we can continue to use is less than 900, right? Something like that. When they say interpret, they want, what does it mean in this situation? All right, second part of the question throws more stuff at you off to the side. And now it just says, all right, now that we know that, what could we plug in and make work? Could I plug in the lighting by itself?
Yes.
Yeah. Could I plug in the lighting and the television?
Yes.
Yes. Could I plug in the 2 fog machines?
Yeah.
No.
Yes.
No.
No, because it's not or equal to, right? I plug that in, that's 900, I plug that in, I'm gonna be at 1800, And magically at 1800, our circuit overloads and we start a fire. Okay, we don't want to do that.
No.
Okay.
all part-
So just be careful of that, right? It's not or equal to there. That's why we had the less than. All right, last thing. Last thing here, with the person next to you, or somebody around you, I would like you to create 3 different inequalities that we could solve, either using addition or subtraction. 3 different inequalities whose answer is going to be this. 3 different inequalities where that's the answer. Go ahead, create it.
Oh, I got one. I don't know. Negative 1 plus. Oh, wait, I mean, my bad. So negative 1 plus y is less than or equal to 0. To negative 1. Oh, positive 1.
Y plus something.
1 plus y. And then you could do. No, but it has to be greater than or equal to. So, I mean, less than or equal to. Yeah, so you subtract 1. That cancels out. But that's why I have to equal at the end. That's what I have to get. No, that's the last thing you can get without solving. Is that the last answer you can get without solving it?
What? What did you say?
Would 1 plus y. And then, hold up, stop, wait a minute. 2 plus y is less than or equal to 3. Is it y is greater than or equal to 0. And then 3 can you like? Yeah. Here you go. True. I'm good at this. Is this on the homework?
Something like this? No, but it might show up on the quicker class. Alright, let's get the volunteers to write something up. Okay, we'll get a bunch of people writing some up. Carolyn, go ahead. Terrence, go ahead. Brayden, go ahead. Weston, go ahead. Everybody else, write one up.
I don't think there's.
Thank you. Go ahead, Chloe, if you want. Yep.
Could I
And make
do?
sure they don't steal mine.
Always make them another.
Oh, yeah. Weston, make up something really stupid. I will make one really stupid.
Something to shoot for.
Gosh, Weston.
Wesley, your handwriting is so big. Wait. Oh.
At least you can see it.
Oh my God, Weston.
Why is there an equal sign? What is this big? Why is there an equal sign? What is
Great
this?
question.
Great question.
All right,
Weston.
so.
I mean, he's not wrong.
He's not wrong.
All right, so this works. And zero both sides, this works. Subtract 100, that works. 3 minus 2 is 1, 1 minus 1 is 0, minus 1, that works.
Hey.
These do not work, why? Why?
Because when you add 0, you're subtracting 0. You can't do that.
Sure you can, you can subtract 0, I just did. I subtracted 0, so it's the same thing. Why is it wrong? It's an equal sign. Gotta have that less than or equal, okay? Hey, I point that out only because, and I know you know what you meant, right? I point that out because we're gonna have problems to solve. And on the test, the answer is this. The answer is not this. And if you write this, it's wrong. Because this is telling me that the only number that works is -1, and that's not true. Any number that's less than or equal to -1 works. So we gotta be careful, we gotta be careful on our side. Okay, gotta be careful. Eventually, the reason why we started doing this is because eventually we're gonna continue doing this with multi-step problems, that sort of thing, where it gets harder. I wanted to throw the basics at you first. Okay, any questions about it? All right, go ahead.